Hello students, in this session we are going to learn another approach for your hardware search, okay, text search. So we have seen how it has been done parallelized according to your adding so many systems or nodes to your existing hardware system. So here we are going to for disk storage, augmented disk storage. What is meant by augmentation? So what you have to do is, suppose if you take disk, I think you have seen how the CD disk will be there. So what I'll do is, whatever the search element will be placed between the read and write. Suppose if I'm taking the read and this is write head, I'll place this search element here and it will scan the complete disk like that. So whenever it is searching that particular thing, whenever that word has been hit, so you will call it as hit. Word is available means you will call it as hit, okay. And the next one is CASSM, the content addressable segment sequential memory. So by the name itself, it has a search element parallel structured in the database. For example, so in the given database, suppose if your database is available, so you'll have all the index terms, and on your disk what is your location of that particular thing will be there, and this will be always parallel. Means parallelly what you are doing, you are going to give the structured data from a database according to the indexed search elements. So this is the CASSM, means content addressable. The content what is available in your particular thing can be easily addressable. So it was developed by University of Florida for general purpose, and it can be used for searching and also for a special search machine called RAP. So relational associative processor, which was developed by University of Toronto. So it is helpful in secondary storage devices also, not only in the primary storage, and it can also do the parallel processing also. Means comparing the cells parallelly. So the next one is your FDF, Fast Data Finder, which is a recent one, and it has been used by many of the algorithms. It was developed by to search the text both in English and foreign languages, okay. So this is pipelining hardware. So this is fully connected pipelining, you know, right? So whenever you have complete system, you will have multiple ways to send the data. So you'll have the multiple pipelines where you can also easily search the data parallelly. So these cells are used to implement VLSI, VSLI chips in the test. Okay, for example, if you take TREC, you have it contains of 24 processes and 3600 cells, and each cell will be a comparator. Okay, so you have designed a chip, so all you have the cells, and each cell is a comparator. So imagine on your secondary memory storage, if you have 3600 cells, what happens? All the cells are capable of searching the text. So how much optimized one? Yes. Okay. So these cells are connected. Okay, I'll show the diagram. Yeah. So these cells are connected. Now if you see here, this is your complete microprocessor memory. You have cell 1, cell 2, cell 3, so on, cell n. So all these are connected to your registers. And what happens here? This is your complete overall database. Whenever your database is there, all these are converted to like this. And whenever you are requesting for any element, these cells will search in the memory for that particular element, and it will easily give you the output. So this is fast data finder architecture. So same thing was represented over here. So you'll have the 20 control lines, and depending upon the current status or result, it will do the comparison. So now what is a cell? It is a cell, as I said, it will have the registers and comparators. So C implies your comparator and R implies your registers where the data has been stored. So if you see the diagram, yeah, C is your comparator and R is your registers. So what are the different functions supported by your fast finder FDFR? Boolean logic including negation, proximity of an arbitrary pattern, variable length of don't cares, term counting and threshold, fuzzy matching, term weights and numeric ranges. All these functions can be done using your FDF. So you can note it as applications which can be used for your further usage. So this is your exact diagram for your FDF. Thank you.